This video is about how to test your model. When we are doing algebraic modeling, we are given a situation with maybe some graphs, maybe some tables of values, and we are asked to find an algebraic model that represents the situation. In this case, a lot of the work has already been done because what we are doing in this video is testing our model, which means we are plugging in some values into the functions and seeing what resulting values we get. Let's say this is number of leaves produced by some plants in a vegetable garden on the y-axis and number of days on the x-axis. I'm looking at this situation and I'm trying to figure out, well, why would this happen? Why would I get a graph of this shape? So, for instance, when the plants are young, they may grow very quickly, and that would be represented by an exponential function. So I figure out what exponential function, what equation would make this part of the graph happen. But then separately, I work with this next part of the graph, which looks like a linear function with a shallow positive slope. And why would that happen? Perhaps once the weather gets warm, the plants start growing not quite so quickly and producing leaves, still producing more leaves, but not as quickly as they did at the beginning. And then I figure out that this linear equation would go with that. Then I have this quadratic section. Why would that happen? Let's say late in the season, the nights start getting cold and the frost causes the plants to stop producing as many leaves. The amount of new leaves produced crashes. But then at this point, I move the plants into a greenhouse to keep them alive for at least the beginning of the winter, and the number of leaves that are being produced climbs again. So I've decided that this section is quadratic, and I've figured out that this is the equation that would go with it. This is an algebraic model. This piecing together of, in this case, an exponential followed by a linear followed by a quadratic is me making a model that explains the math behind this situation, or that suggests mathematical equations that could cause this situation to happen. Now we're at the stage of testing the model. To test, I'm being asked to plug these 3 points into the functions. X equals 1 will happen here in the exponential section. I can't plug x equals 1 into this section or that section and get a meaningful answer, because x equals 1 is happening around here early in the along the x-axis, and that's only happening within the area where the exponential function happens. So I'm not trying to plug all 3 of these points into all 3 functions. I'm trying to plug x equals 1 into the first function, x equals 8 into the second, and x equals 16 into the third in order to test my model. Plugging, of course, is simple math. We replace x with 1 in our equation. 3 to the 1 is equal to 3, so our equation becomes y equals 2 times 3, y equals 6. We have our answer. Plugging x equals 8 into this function, we have y equals 3/4 of 8 plus 16. 3/4 of 8 is 6. So I have y equals 22 as my answer. And then plugging x equals 16 into the third function, we have 16 minus 20 inside our bracket, which gives -4. We square the -4, and we get 16. 1/4 of 16 is 4. 4 plus 2 equals 6. We have our answer, y equals 6. That's all there is to it when you are being asked to test your model. But don't create an algebraic model in a large exam question and then neglect to do this step of testing it at the end. The question has provided us these points because within the context of the situation, they want to see some answers that we are applying with the model that we chose to apply.